Okay, today we are doing right triangle trigonometry and we are solving for unknown sides. So we're going to start by reviewing a triangle. So in a triangle, the longest side is always called the hypotenuse. Okay, and then this is one leg of the triangle and this is the other leg of the triangle. Okay, now we're also going to revisit SOHCAHTOA. So a lot of you learned that in Math 2H, and what the S stands for is if you want to know the sine of an angle, you take the opposite over the hypotenuse. So in this particular problem, because this is the angle, even though a triangle has 1, 2, 3 angles, because this is the angle theta, and that's what we're asking, this is the side opposite theta. And then this right here, this side is the side adjacent. So it touches the adjacent side. It does not touch the opposite side. And then again, the longest side is the hypotenuse. So when you want to find the sine of an angle, it's opposite over hypotenuse. So like Chief SOHCAHTOA, S-O-H, so. And then the next one is cosine, and that's adjacent over hypotenuse. So that's the C part, C-A over H. So if I want to know the cosine of this angle right here, I just take this leg and put it over that leg. And then the last one is tangent, and that's opposite over adjacent. So that's going to be opposite over adjacent. Okay, and that's the TOA part. We also learned when I was in high school, some old horse caught another horse taking oats away. And then there was some old hippie caught another hippie tripping on acid. There's all kinds of interesting ways to remember that. Now you might be wondering what these guys are right here. These are called the reciprocal functions, or as I like to call them, refliprical. And the reason why is because, look, sine and cosecant are reciprocals. You just flip your fraction. So you might be asked a question like over here, which says the cosecant of theta, and you're like, oh my goodness, I don't remember cosecant. Who does it go with? Who's its reciprocal? Well, we go to Steele Canyon High School. Well, maybe you do, but we're from Steele Canyon High School. So if you notice, between sine and cosecant, there's one that's an S and one that's a C, like Steele Canyon. And then if you go to cosine, there's secant, which starts with an S, and its reciprocal is cosine. So people have a tendency to put cosine and cosecant as reciprocals, but that would be two C's and not an S and a C, so you always need one S and a C. Now that pattern doesn't work for tangent and cotangent, but I think you can figure that one out on your own. Okay, so let's get into the first example. We have a triangle here, and the angle that we're referencing is theta. So say theta. This is how you pronounce this guy right here. That's a Greek letter theta. So we are looking for the sine of theta. So sine, you're going to have to remember this. Sine starts with an S, SOHCAHTOA, so this is opposite over adjacent. Nope, opposite over hypotenuse. Okay, so that's opposite over hypotenuse. So when you make your triangle with respect to this angle right here, not with respect to the other angles, but with respect to theta, that's the opposite side, this is the adjacent side, and this is the hypotenuse. The hypotenuse is easy because it's always the longest side. So opposite is 8, hypotenuse is 10. So if you don't see that you can reduce that, then into your calculator, you need to do that. So you have 8 divided by 10, which gives you 0.8, and then you go math, enter, enter, and you'll see it's 4/5. So that's 4 over 5. Now it's really easy to go ahead and do the reciprocal right away because you just flip it. So that's 5 over 4. Next one is cosine of theta. Cosine, Chief SOHCAHTOA is telling us SOHCAH. So that's that right there, and then adjacent to theta is 6, and the hypotenuse is 10, and when we reduce that, we get 3 over 5. Sweet. So then the reciprocal, cosine and secant are reciprocals, that's 5 over 3. The last one is tangent, which is opposite over adjacent. And for that one, you're going to do opposite, which is 8, over adjacent, which is 6. So then when we reduce that, we get 4 over 3. So then the reciprocal of cotangent, the reciprocal of tangent is cotangent, and it's going to have a value of 3/4. Alrighty? So I just wanted to point out, if you did h over a, or h over o here, then you would get h, which is 10, over o, which is 8, which reduces to 5 over 4. So you can do the math for those two if you want as well. But if you're already doing the math for these, then it's just easier to just flip your answer that you got for them, because that's the whole point. Like, math is full of patterns, and those are the reciprocals. Alright, now this one, we're not given a triangle, but we're asked to find the cosecant of theta. So the other thing that we're going to be using for this one that you might want to write kind of over here is the Pythagorean theorem. So the Pythagorean theorem says the legs of a triangle squared are equal to its hypotenuse squared. So when you add the legs of a triangle that have been squared, you'll get the hypotenuse squared. So we're going to need that for this problem. So let's set this up real quick. Tangent is opposite over adjacent. So I'm just going to draw a little, it looks like an XY axis, because I'm just going to draw a triangle on here. We're going to be using this in the future, so I'm just making a right triangle using that. And if I put theta right there, again, you can draw a triangle not on the axis, but I know where we're going, so you're going to get in the habit of doing this. So this would be the side opposite. So tangent is opposite over adjacent, so 7 is the opposite, so we can put a 7 here, and 8 is adjacent. So this is 8, and it wants us to find cosecant. So cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so that's all right here, but I'm trying to help you think through it. So sine is SOHCAHTOA, so opposite over hypotenuse, and this is the reciprocal, so this is hypotenuse over opposite. Well, look at this. We have opposite, but we don't know the value of the hypotenuse yet. So the way we're going to find that is the Pythagorean theorem. So we're going to do 8 squared plus 7 squared equals c squared. And so we're actually not going to call it c though, just because of where we're going. I'm going to go ahead and have you guys call it r squared. And again, this is kind of like this. X squared plus y squared equals r squared is another way to write the Pythagorean theorem. And I'm having you guys do this because of where we're going to be going later in this chapter. So it's the same thing. Don't let it trip you up or anything like that. So we're going to follow order of operations. So we're going to do adding. So 64 plus 49 equals 113. And then what I'm going to do is square root both sides. So I'm just rewriting it, and I get r equals plus or minus square root 113. But in the context of a triangle, the negative does not make sense. So we just have 113. So this is square root 113. So then we need to see if we can simplify that. I'm telling you, you can't simplify it. So we're going to write cosecant of theta. You have to put the theta there for this to make sense. It's kind of like the argument of a logarithm. You have to have a number next to the logarithm. You have to have a symbol like theta, or an actual angle like 60 degrees next to a trig function like cosecant, sine, tangent, whatever. So this is going to be hypotenuse over opposite. So that's going to be the square root of 113 over 7. Okay? And that's our final answer. Great. Okay, moving on to the next one. We are given that the sine of the angle equals 5 over 6. Find the cosine of the angle. So if we're writing steps, 1, we're going to label the fraction. And if there isn't a fraction, you're going to make it a fraction by putting it over 1. So this is going to be opposite over hypotenuse. Then we're going to make a triangle. So I'm going to put corresponding triangle. Then we're going to find the missing side. And then we are going to find the trig function. So I just took up a lot of room to write those steps, but we are fine. All right, so here's this, and we have opposite, so I'm just making some triangle right there, and I'm labeling theta. So opposite is 5, and hypotenuse is 6. So I don't know what this is down here, so I need to find it. So it's x squared plus y squared equals r squared, or a squared plus b squared equals c squared, but you're progressing in your math education, so it's not that big of a change. So I don't know the horizontal, so I'm going to call that x, so that's x squared. And then y squared is 5 squared, and this is considered your radius. So your hypotenuse is considered your radius, so that's 6 squared. So be careful, x squared plus 25 equals 36, subtract 25, so x squared equals 11, square root. So x equals plus or minus radical 11. Negative case doesn't make sense, so that's square root 11. And then we're going to squeeze this in right, let's squeeze it in down here so it makes sense. The cosine of theta equals, so again, we have our theta, adjacent over hypotenuse, and this is now adjacent because this was opposite, and this is your hypotenuse, so we get square root of 11 over 6. So that is the cosine of that angle. Alrighty, now they give us a triangle. It's triangle ABC, and just a friendly reminder, angles are capital letters, sides are usually notated in lowercase letters. Find the length of side A and the length of side B. So we're okay. We need to find the length of side A. So what we're going to do, this one's a little different. We are going to set up a trig function, and we're going to use our calculator. So with respect to this 54-degree angle, this is opposite, and this one is adjacent, and this one is the hypotenuse. So if I want to know A, I'm going to need to use opposite over hypotenuse. Which trig function is opposite over hypotenuse? Oh, that's sine. Alright, but I actually have the angle. So I'm going to write the sine of 54 degrees equals A, which is opposite over 20. So I set up a little equation there. We're going to set up another one in a minute. And so I'm just going to multiply both sides by 20. So I get A equals 20 sine 54 degrees. So before we plug that into our calculator, you're going to hit mode and make sure that you're in degree mode and not radian mode. We'll get to radian later. So we get A equals, and then we have 20 times the sine of 54 degrees, which is 16.18, and it says round your answer to 1 decimal, so 16.2. It also wants us to find the length of side B. So with respect to this 54-degree angle, that's the adjacent over hypotenuse side. So we're going to do adjacent over hypotenuse would be cosine. So it's very similar. Multiply both sides by 20. So we get b equals 20 cosine 54. Make sure your calculator's in degree mode. You plug it in. Boop, 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 boop. 20 cosine 54. And we get 11.8. Fantastic. All right, we're already on the back side. Sweet. This one says solve for y using a calculator. Use your answer to one decimal place. So what do? Here's our angle that we're referencing. This is an opposite side, and this is the hypotenuse. What makes that trig ratio? What goes with that fraction of opposite over hypotenuse? That's sine. Sine of any angle is opposite over hypotenuse. So if I have the angle, which is 32 degrees, I have the sine of 32 degrees equals the opposite leg over the hypotenuse. So then I multiply both sides by 7, and I get y equals 7 sine 32 degrees. And I really encourage you guys to be plugging these in your calculator and not just copying my answer, just to make sure. You think you're going to know it, but history does not prove that for all kids. So 3.7. Now, if there were units on this, we would put the unit like meters or inches or whatever, but there's not, so we're good to go. All right, this one says solve for x using a calculator. Round your answer to one decimal. So the angle that they give us is 38 degrees. So this is actually the adjacent side because it's touching, and then the longest side is always the hypotenuse. So this is actually going to be the cosine of the angle. So that's because cosine of theta, any angle, is adjacent over hypotenuse. So we take the cosine of 38 degrees, and we get x over 21. Multiply both sides by 21, and you get 21 cosine 38 degrees, which gives us 16.5. Now, there is one thing that I just want to talk to you about, because I know some of you are super intelligent and you know how math can work differently, and that there's more than one way to do something. So here is the other way to do it. So some of you know that the angles in a triangle add up to 180 degrees. So if they add up to 180 degrees, and this is 90 and this is 38, I can actually find the missing angle even though it's not marked by subtracting. So this angle here is actually 52 degrees. So I'm drawing a separate triangle just because I want you guys to see it this way. So this is 52 degrees, this is x, and this is 21. Now, if I wanted to use this angle instead of this angle, look at x. Is x still the adjacent side? No, now it's the opposite side, but 21 is still the hypotenuse. If I had this, it would be the sine of 52 degrees equals x over 21. So then x equals 21 sine 52 degrees, right? Times both sides by 21. Look what happens because of the relationship between sine and cosine. We get the same answer. Yay! So it doesn't change the length of the triangle just because we use the other angle. It's just easier to use the angle that they give you, right? Because if you try and use the other one, then you have to relabel the sides of the legs of the triangle. So just be aware of that. Okay, let's finish this off. We got two more examples. It says the ladder is leaning against a building with its base 3.5 feet from the wall of the building. All right, so here's our ladder. leaning against this really cool building. Here's the windows in the building. It's obviously not to scale. And the base of the ladder is 3.5 feet away from the wall. It creates a 70-degree angle with the ground. So the ladder creates a 70-degree angle with the ground. Find the length of the ladder. So they want to know this distance right here. So we can either label it H for hypotenuse, or we can label it R, or we can label it C, because really it's the hypotenuse of a right triangle, right? So we just need to figure out this side right here. This is the adjacent side, and this right here is the hypotenuse. So if you have adjacent and hypotenuse, the ratio that you can set up is cosine. And now things just got a little bit more different. So what this is we have the r down in the denominator. So what we're going to do is we're going to put this over 1, and then we're going to multiply both sides by r. You don't really need to put it over 1, that's why I was just saying but it's fine. There's 2 ways to do this, so I'm going to go with this approach. I'll show you the other one in class. Okay, so we get r times the cosine of 70 degrees equals 3.5. My job is to solve for r, so I need to divide both sides by the cosine of 70 degrees. Actually, I'm going to talk about it now. So I had you guys put this one over 1. The reason why I had you put that over 1 is because you can just flip your fractions. So you can do this right here. If you have cosine of 70 degrees equals 3.5 over r, and you want the r to be in the numerator, then just flip both fractions. It's kind of like what we were doing in the exponent chapter when we said because the bases are equal, the exponents must also be equal. The numerator and denominators must be equal to make this statement true, so we could flip this, and then what we can do from here is multiply both sides by 3.5, and when you multiply fractions, that would end up in the numerator, just like it did over here. So no matter which way you do it, whether or not you flip the fractions or multiply both sides by r, you'll get the same thing. And you'll see me do it, if that confused you, in the next problem as well. Or on a homework problem. I don't mind explaining it again. So that ladder is 10.2, and we do have units. The unit is feet. Alright, last problem to do right up here. Suppose you're flying a kite and it gets caught at the top of the tree. So here's my tree, great tree. And your kite gets caught at the top of the tree. There's your kite. You've let out all 100 feet of the string for the kite. So here you are. You're sad. You've let out all 100 feet on the string of the kite. And the angle that the string makes with the ground is 75 degrees. And instead of worrying about how to get your kite back, you wonder, how tall is that tree? Round your answer to the nearest decimal place. So what we're looking for is this distance right here. I'm going to call it y since it's a height. And if we're looking for that right there, then this, in respect to 75 degrees, is opposite. And this right here is going to be the hypotenuse. So that's going to be a sine. So sine of 75 degrees equals opposite over hypotenuse. Multiply both sides by 100. So your height of your tree is 100 times sine of 75 degrees. Which equals 96.6 feet, right? Because it's in feet. So we need that unit. And that's all that we're doing for this unit right here in 17.1.